These exponential graphs and exponential relationships are most commonly used in any type of population study, the COVID study and stuff like that, when we're looking at the rate of growth of something like a virus or a bacteria. It's usually based in an exponential language because once it starts going, the rapidity of how it replicates is best demonstrated by an exponential relationship. So with this question, it talks about population growth, and this happens to be human population growth. And they're looking at York, which is Southern Ontario, Toronto area, projected to grow until this year at this rate, where n is the number of years after 1996. So if we're going from 1996 up, we're looking at what are the trends. So if we were to calculate using a calculator and plugging this value in, when we plug in an x value of 0, and you go 61000 bracket 1.029 close bracket raised to the 0, because that's the first one we're doing, your population is 610,000. Notice that is this part of the equation. So when we put in a number of 0 to find out our initial population, it's like this whole part canceled out. And that's because anything raised to the exponent of 0 is 1. So it's like 610,000 times 1, because this whole thing would have gone to 1. Okay, let's calculate it for 10 years. 1, 0. I get, on my trusty dusty calculator, 8, 1, 1, 8, 6, 4.56. Now, populations are weird. When you're dealing with a population of something like a species number or a number of things, rounding rules don't apply. Because if this 5 should say that we round that 4 up to a 5, but I can't magically create a person. So I would leave this if I were graphing or if I were stating this information as an answer, which is good to know for some of our word problems. I would leave it as that. Even though the 5 normally would round that 4 up, because we're talking about people, you can't create more of a person. So when we're talking about populations, you leave them at the lowest value. So let's try 20. So I can calculate a value. Well, it doesn't want to let me do that on my calculator. And you know why? I think it's because of my window. My window is set to X max of 50. Okay, now if I graph. Yeah, give me a second now. Welcome to my life. This is why I don't record anything. 20. Okay, here we go. 1, 0, 8, 0, 5, 3, 1. Let's calculate at 30. 1, 4, 3, 8, 1, 0, 6. And let's calculate at 40. 1, 9, 1, 4, 0, 1, 2. So those are our values for the estimated projected growth in the population. So it started off in 1996 at 610,000. 40 years later, it's looking to be at 1.9 million. Okay. And we've got that growth shown here. Now, this is saying in thousands. 600,000. As soon as you get to this, a thousand thousands, you're dealing with a million. Okay, what is the y-intercept and what does it represent? The y-intercept is the initial value, which is our initial value when time of 0, and it is the initial population. So for any type of growth question, money question, investment question, your y-intercept represents how much you began with. Okay? What is the projected population in 2031? In order to figure out a projected population in 2031, we have to say, well, what's 2031 minus 1996? How many years have gone by? So 2031, back to using my trusty dusty calculator, minus 1996, 35 years? I always double check on a calculator. So we are going to find out what the population is when we've got 610,000 multiplied, what is our base? 0.1 or 1.029. 1 point raised to the 35. Okay. So calculator, you could put this all in as long as you remember to use that button. So 610,123 bracket 1.029 close bracket raised to the 35 gives us, not red, 165,908,2. Therefore, the population in 2031 would be 165,908,2. All right. And here we go. The actual population at the end of 2009 was that. So they gave us the real population. We could calculate with our equation, we could calculate what it should have been. And then the question wants you to know how far off was it? So let's calculate what it should have been, and then we'll compare it to what it actually was. So it should have been 2009 minus 1996 is going to give us our time. 2009 minus 1996, 13 years. Let's use our population equation. And let's 1.029 raised to the 13. Let's calculate what it was supposed to be based on that estimation, based on that formula. Raised to the 13. And we get 8, 8, 4, 5, 6, 4. So this is what it was supposed to be. And this is what it was actually. So it's supposed to be 884,564. And it was actually like 1,032,606. How far off Well, we would have to go 1032606. That's supposed to be a 6. And we'd have to subtract the how much it was supposed to be. And this could go either way. Like you could either have like more people than you thought you were going to get or less people. It doesn't matter if it was more or less. You're just going to say, oh, well, that was a difference of 884,564 of 148042. About 150,000 people. So the estimate was um, off by 148,042. Now, a communication question I could ask you for that would be come up with what are some reasons that the estimated value might be off? Well, maybe let's say if it was lower, maybe a lot of people moved out of the area because industry left, or if it was higher, maybe a lot of young families moved into the area and all started having babies. Like they're like just trying to make a connection with the math to real life stuff.